Hey guys, I welcome you all to the discussion of this new advanced problem which was asked in JEE 2024. In JEE Advanced, questions often look simple on the surface, but they hide a layered conceptual twist. Today's problem is a mixture of S.H.M and Young double slit experiment from the wave optics chapter. So let's study the question first. In a Young double slit experiment, each of the two slits A and B, as shown in the figure, are oscillating about their fixed center with the mean separation between them is 0.8 millimeter. The distance between the slits at any time t is given by d is equal to 0.8 plus 0.04 sin omega t mm, where omega is equal to 0.08 radian per second. The distance of the screen from the slit is fixed, that is 1 meter, and the wavelength of the light used on the slit is 6000 angstrom. The interference pattern on the screen changes with time, while the central bright fringe, that is the 0th fringe, remains fixed at point O. The maximum speed in micrometer per second at which 8th bright fringe will move is. So beta, you can see in this problem, the slits are oscillating. So beta, if we talk about the 8th bright fringe, so what will be the position of the 8th bright fringe? That can be written as y is equal to n lambda capital D by small d, isn't it? To find the velocity, the position must change with time. So velocity is basically the rate of change of position. So we can find the velocity as dy by dt, isn't it? So we can differentiate d by dt of n lambda d to the power minus 1, because the d is changing, as the question says that d is dependent on time itself. So only small d is changing. So we can take n lambda capital D out of it and differentiating d by dt of d to the power minus 1. So what we will get is v is equal to minus n lambda capital D upon d square into d by dt of d. Okay, so the chain rule which I have used. Now we want to find the velocity as a maximum. So for this, what we're gonna do is, as we can see, this velocity is dependent on the first differentiation of this d. So we're gonna differentiate this d as well. So d is equal to 0.8 plus 0.04 sine omega t. So its differentiation will come out to be as d by dt is equal to 0.04 and cos omega t into omega. Okay, isn't it? Now, if we want this velocity to be maximum, this d by dt should be maximum. And if we want this d by dt as maximum, we can say the cos omega t should be 1. So if cos omega t should be 1, then sin omega t must be 0. We can see that. And if sin omega t is 0, then d is equal to 0.8, isn't it? 0.8 mm we can write. So what we will have finally as V maximum, that is n is equal to 8th bright fringe, lambda is equal to 6000 into 10 raised to power minus 10 because it is in angstrom, into capital D. Capital D is 1 meter, so we can write it 1 into d by dt. d by dt is 0.08 and into 0.04. So I have put the values beta from here. D by dt 0.04, it is here, and omega I have put from the question 0.08 radian per second. Now we are going to put d square. Small d is 0.8, so 0.8 square, so 0.8, and for millimeter we can write 10 to the power minus, because it is going to be millimeter square, so 10 to the power minus 6, isn't it? So now on solving these, we will get beta 24 micrometer per second. So if you like the lecture, please like and share it. And if you're new on the channel, you can subscribe to the channel always, for supporting me. So we will meet in the next lecture. Okay, till then, have a great day.